Air turbulence refers to irregular and often unpredictable air movements that an aircraft encounters while flying. It's a common phenomenon and can vary in intensity from light to severe, affecting the comfort and safety of passengers and crew. Here's an overview of the key aspects of air turbulence. Causes of turbulence. Thermal turbulence, caused by rising warm air, often encountered during sunny conditions and over land. Mechanical turbulence occurs when airflow is disrupted by terrain, buildings, or other obstacles commonly found near mountains or tall structures. Clear air turbulence, CAT, happens in clear skies, often at high altitudes near the jet stream, and is difficult to detect because it's not associated with clouds or weather systems. Wake turbulence, generated by the wake of another aircraft, especially large ones like jets or heavy cargo planes. Frontal turbulence occurs along weather fronts, especially cold fronts, where warm and cold air masses meet. Convective turbulence, associated with convective weather patterns such as thunderstorms, where strong updrafts and downdrafts are present. Types of turbulence. Light turbulence, slight erratic changes in altitude and/or attitude. Passengers may feel a slight strain against seatbelts. Moderate turbulence, greater intensity with rapid bumps or jolts. Unsecured objects move and passengers feel definite strains against seatbelts. Severe turbulence. Large, abrupt changes in altitude and/or attitude. Aircraft may be momentarily out of control. Unsecured objects are tossed about and walking is impossible. Extreme turbulence. Aircraft is violently tossed about and is practically impossible to control. It may cause structural damage. Safety and response, pilot action. Pilots receive weather briefings and updates, use radar to detect thunderstorms, and communicate with air traffic control and other aircraft to avoid known turbulence areas. Passenger safety. Passengers are advised to keep seatbelts fastened when seated, follow crew instructions, and store loose items. Aircraft design. Modern aircraft are designed to withstand significant turbulence, with structural components tested to handle stress well beyond typical turbulence encounters. Technology and forecasting. Weather radars. Onboard radars help detect weather systems that could cause turbulence. Turbulence prediction models. Meteorological models predict areas of likely turbulence, aiding in flight planning and real-time navigation. In-flight monitoring. Aircraft systems continuously monitor air conditions, and some airlines use real-time data sharing to inform pilots of turbulence reports from other aircraft. Common misconceptions. Danger level. While uncomfortable, most turbulence is not dangerous. Severe turbulence can be hazardous but is relatively rare. Turbulence versus safety. Modern aircraft are incredibly resilient, and turbulence is accounted for in their design and pilot training. Understanding air turbulence helps alleviate fear and prepares passengers and crew for the variations in flight conditions that are a routine part of air travel.